All right, good morning, everybody. Looks like it's kind of in a weird spot. Let's fix that. Okay, there we go. Okay, there we are. So good morning. Happy Saturday. I am, I guess let's do a quick introduction for anybody that might be new. My name is Tim, and I go by Foamy Guy on GitHub and Discord. We are working on CircuitPython stuff. Last night we started kind of plugging away at this grand idea of on-device testing using automated CI workflow. I'm continuing with that today, but in a slightly different direction. Thank you to David. Let me also reply to one of these from David in the chat here. This seems like an interesting way to do it as well. So, let's finish up the introduction as well, though. So, we're working on CircuitPython stuff. If you're new to this and you don't know what I'm talking about, a good place to go to check out to learn more is CircuitPython.org. Basically, though, what's going on is we have CircuitPython, which is a version of Python that runs on tiny computers called microcontrollers. So there's a bunch of pictures of them here. You can see there's lots of different shapes and sizes and capabilities. Different ones have different built-in hardware, like e-ink screens or LCD screens, or this one can hook up to an RGB matrix screen. This one has keyboard keys on it. It's like a little macro pad there with a small screen and a knob as well. So all of these different things come in different configurations. We have a version of Python that runs on these devices. So we write our Python code, we save it on this device, and it will execute the Python code for us. So that is kind of like high level what we're working on. And then specifically, I'm working on ways to interact with these devices for automated testing. So if you could have one of these plugged in and you could run some automated tests and some statistical gathering of like memory usage and things like this, this would be quite helpful for us. So that's what I'm working on today. CircuitPython is an open source project. Again, you can learn more at circuitpython.org. Also encourage you to join us down in the Discord. If you want to learn more, that's linked down below, adafru.it/discord. That's also the chat that's on the screen down below me there. And it is in the live broadcast chat right now. That's the channel that's showing there. If you would like to help support the project, but you're not necessarily interested in coding or testing or helping on a technical front, another thing you could do is purchase hardware from Adafruit. So Adafruit.com is their website. They create hardware and software. They're a company based out of New York, the United States. They create all of these little hardware devices. Lots of the different microcontrollers that run CircuitPython are created by Adafruit, but in fact, there are even more created by external folks at this point as well. So that's amazing to see so many other folks working on CircuitPython devices as well. But in addition to the microcontrollers, they also have all of the things that you can like plug in to interact with. So 7 segments, 14 segments. What else do we got here? Some little lights shaped like succulent lights, skulls, more microcontrollers, sensors, buzzers, beepers, LEDs, knobs, switches, buttons, all kinds of stuff that you can hook up to the microcontroller and then interact with using that CircuitPython code. So head to Adafruit.com, get some goodies. Thank you to them, and definitely thank you to anyone who does purchase hardware from Adafruit, because they are the ones who are providing the financial backing for CircuitPython. They're paying the folks who work on the project full-time and other folks like me who work on the project part-time. So huge thanks to Adafruit, and huge thanks to anybody who does want to purchase hardware there. Let me reply to David here. This is an interesting thing. I did not know this was a thing, but David was catching up on the stream last night. David G in the Discord here, and it's while he was catching up, he had this idea about self-hosted GitHub runners. So to kind of set the stage for where we're at, if you missed yesterday's stream, I was kind of trying to think about how we could make this infrastructure where individual volunteers could keep a CircuitPython device plugged into a computer, running 24/7, connected to the internet. Maybe just a Raspberry Pi or maybe a PC. They keep that little microcontroller plugged in, or perhaps even multiple microcontrollers, and then we have some way within our GitHub actions to like ask that local computer to run some tests on the microcontroller, whether that's just install a library and check the memory, or that is even more complex things like install a library and run some test suite of code against it and return the results of those tests or something like that. That would be pretty helpful to us during library development and even potentially core development as well. So that's kind of like the overall need that we're trying to solve for, is automated testing on the microcontroller specifically. Automated testing in the cloud is one thing, and we can do some stuff on that front. There's some things we can take advantage of, and there's lots of things we do take advantage of already with the actions workflows. But automated testing on the microcontroller, this would be kind of the next level up for us, since a lot of the software we write is really specific to these hardware devices. We need a way to test with hardware if we want to be most effective. So that's what I was working on last night. I started working on a very kind of rudimentary proof of concept using WebSockets. And David was watching that stream and mentioned this idea, which is these self-hosted GitHub Actions runners. So I found this page, which talks about it a bit. This is talking about doing it on a Raspberry Pi. From what I understand, you could do this on your own PC as well. So I'm going to attempt to set it up on a Pi. If we run into trouble, then I might attempt to use my own PC for it. We'll see how we end up. Basically, the idea here is you download some stuff, you install some stuff, and then you run a little script on a host computer, be it a Raspberry Pi or whatever else. And then you set up your repo to, on specific workflows, to run it inside of your self-hosted runner instead of inside of the GitHub cloud infrastructure, which is interesting for a couple of reasons. This article makes it seem interesting because you can save, GitHub computing power. So if you're a free GitHub user, there's a cap on how much actions time you can run or something. I don't know the exact way it works. I believe CircuitPython and Adafruit are an enterprise GitHub customer, I believe. So I think that cap is either higher or unlimited or something. So that bit of it is not necessarily something that we need to optimize for, at least right now today. But it is interesting. It's good to note because we do, the actions do a lot in CircuitPython, making all the builds, especially the core actions. There's a lot of stuff they do. If we could offload that, if that does lower cost or something, that might be interesting. But for us, in fact, I think the more interesting thing about that running the self-hosted thing is that you can have other hardware hooked up to it, if I understand correctly, right? So if we self-host a Raspberry Pi runner, we can have our microcontroller plugged into the Raspberry Pi, which then means our GitHub action can kind of like, not quite directly, but pretty darn close to directly interact with that microcontroller, which is exactly what we want to do. And this kind of cuts out the middleman of the WebSocket server, which is how I was thinking about it last night. So if we could get this to work, it means there's way less infrastructure. We don't need that central server that I kept talking about last night, because the central server essentially is GitHub in this case. The GitHub repo that's set up to use this self-hosted runner becomes that central server component within the larger idea here. So we can kind of go straight to that client PC, which can then turn around and go straight to that microcontroller. So yeah, let me do finish this. So super neat idea. Thanks for mentioning that. Going to explore self-hosted actions runners a bit today. We'll call it GitHub at home. Nice. They should call it GitHub at home. Yeah, they totally should. That's super cool. Also, I'm glad you're here, Neradoc, as well, because one of the things that we can do to make this easier. So like last night when I was running some of my stuff, I was just hard coding the device, I guess, serial path, the path to connect to the device with TIO. But you, of course, Neradoc in the chat there, has this tool called Disco Tool, which will find this stuff for you. So if our actions can make use of this, it would make the whole idea of using multiple devices a lot easier, because this helps you manage, list out all the devices, and then target individual ones for individual things. So I will try to kind of bring this into the mix for finding and targeting those devices. So that is where I'm at. So where we're starting is we just need to get this self-hosted runner thing set up, which this page describes the process for. You basically go to your actions, settings page, you click a thing to add a new self-hosted runner, and you choose, I think, an architecture or something, and then it shows you a bunch of commands that will let you set up that runner. So I have SSH open on a Raspberry Pi right here. I have a Disco Tool set up, and I have a device plugged in, and I ran the command there to list it out, so we can see my single device there. One thing I noticed when I did install Disco Tool, I had to upgrade my 6, but that could also just be because I had a super old, like, I don't even know when I put this Raspberry Pi image on there. It's probably at least a year old, so probably just had an older version. But I got something like this thing here. I got originally something about 6 moves, but I just didn't upgrade. After that, we're all good. So this is the Pi that we're connected to. This is where I'm going to do the setup for the self-hosted runner. I have this page open here. I was going to try not to show that portion of it, but I failed, so oh well. Hopefully nobody will self-host run jack my token thing here. Delete it afterwards. So basically, yeah, I'll show you where this was. Settings, and then actions, and then runners. We choose a type, so I assume we can do just a PC here, right? If you had a Windows PC or a Mac computer, I assume you could pick those. In my case, I have a Raspberry Pi, so it's Linux. The architecture is ARM on my Raspberry Pi because it is a Raspberry Pi 3B Plus, I think, and I ran a command, and I think that I figured out that it's ARM7, which I think is 32-bit ARM. There's also ARM64, which I think the newer Raspberry Pis might be, but I'm not sure. So this is what I'm doing, is ARM and Linux. And it tells us these actions, or these commands right here to set up. How's it going, DJ Devin? Looks like 6 is a dependency for PyUdev. I gotcha. Okay. So yeah, we can kind of just build. Oh no, let's put this one over here. It's probably getting covered up though, huh? Yeah, kind of. Good morning, Paul Cutler and Johnny. How's it going? Yeah, local runners, I hadn't heard of this before. It's a thing that I had thought about before, just from the angle of like, what if we could avoid some of the, like offload some of the work that GitHub does, because we do a lot of work in GitHub, but it seems like we have pretty much unlimited. I don't know the way the enterprise pricing or anything works, but doesn't seem to be a problem that we do that much work there. But I had never considered it. Well, I never knew that it was actually a thing you could do. Like when I thought of this, it was just like, wouldn't it be cool if you could do that? I have no idea when they introduced it either. It's possible they created it since then. But I never considered the idea of using hardware from it. That is that kind of makes the jump for us to being like really promising, I think. Yeah, we could go. Yeah, we could go here. So that's gonna make a folder called Actions Runner and move me inside of it. Then we're gonna download something from GitHub with curl. tar file, Linux ARM 2.94. It's the Actions Runner. tar. I guess is just like the release bundle or something. Octopi uses it to test newly built images on Raspberry Pis and says it works fantastic. She says it works fantastic. That's pretty smart. Yeah, Octopi is in a similar situation as us where they're creating software, they're writing software, they're testing software, but it's really made for a specific piece of hardware. Theirs, of course, is a Raspberry Pi. Ours are the microcontrollers, but pretty similar needs. That's really good to hear. That project is having success with it. We got this. We downloaded it. Yeah, we'll validate the hash. Why not? Okay. I think that's a good output, probably, right? Basically put the image on the device, test that it works locally. Of course, for our devices, we really need to test code instead. Eventually, I think we could get to the point of testing code. I mean, I think if we can get to the point of just measuring RAM import, like that's a lot more than we have access to today, like quantified information. Would that make GitHub a coprocessor to some extent for some things? Yeah, kind of. It would make them. Well, I mean, they kind of are already today, right? The actions already essentially are a coprocessor for our, our whole project, because the actions are doing a bunch of things after we make commits, like building MPY files in the libraries, building the core images, the UF2 files and bins in the core. All that stuff is happening with actions. So today, kind of GitHub servers, GitHub cloud servers are essentially kind of coprocessors to a lot of our systems, a lot of the things we do. What this would do was would make it so that GitHub and my or your or Neradox, GitHub and our Raspberry Pis or our PCs work together to be that coprocessor. We kind of gain an additional coprocessor of that person's PC or Raspberry Pi. One thing I haven't figured out yet is what it does when there's multiples, because that's one thing we need, I think, our system to support is it can't just be one device, right? We can't just have one Raspberry Pi and one microcontroller and that does everything, right? I think we need ideally multiple people. I'm hoping we'll be able to get it set up where anybody can follow some relatively simple steps. We'll build a learn guide out of it or whatever. Somebody can follow the steps. That's going to get their Raspberry Pi or their computer set up to where they can just leave it plugged in with the microcontroller and running 24/7. And then I'm hoping that GitHub will be able to like dole out those tasks like to multiple ones of those clients. So, if 10 people have them plugged in, and 2 of them are just offline because the power went out or it crashed or whatever, then like we still have 8 available. And I'm hoping GitHub is gonna figure out how to like send the jobs to one of the available ones. But I also don't know how that bit of it works yet. Tanner just talked about this need when we were discussing unit testing. Yeah, I've heard Scott talk a couple times. I think he also found a startup. I don't know the name of the startup, but somebody reached out to him, or he was talking to him at one point about this automated testing on devices. And they did. I think they were a mobile thing, which this has a lot of parallels to mobile automated testing as well. There are services that offer this exact kind of thing where you can run your automated tests against hardware. In that case, it's mobile phone hardware, right? Android, iOS devices. In our case, ultimately, we're interested in the microcontroller, but we could get there via the Raspberry Pi or the PC. Okay, so we got this downloaded, extracted. We got all of this stuff here. Configure, we're going to do this. Distributed runners, yeah. Copy this. Want to buy this NFT? I will pass. Yeah, probably we shouldn't be showing token, I'm guessing, but I will go back and delete it afterwards. I'm not entirely sure what the token does or what token it is. Authentication. Am I supposed to log in or? Oh, okay. Enter the name of the runner group to add this runner to. I don't know. What's a runner group? This page. Oh, let me use this other. Does this page say anything about? No, doesn't really say anything about the name. I don't know what's a runner group. I guess we could just say pi runners. I don't know. So default? Let's try default. Or do I need to make a runner group here first? I don't know. We don't have any other runners, so we don't have any runner groups yet. Oh no. Per group, running on a per group name. Now we're getting fail on this over and over. This change or something? So we'll just go enter for default. Enter the name of the runner. Foamy guy, pi 0. No, I shouldn't call it pi 0, I guess, because it's not a pi 0. But I was thinking like the 0th index of my pi's, so like if I set up another one, it'd be 1 or whatever. That's fine. Yeah, we'll do that. This runner will have the following labels: self-hosted Linux ARM. Enter any additional labels, label 1, label 2. Microcontroller tester? I don't know what labels are for. This might be part of the way we target it, though, I guess. As long as, like, if everybody chooses microcontroller tester as their label, maybe our action can just look for any available microcontroller tester, and then maybe that's how the distribution can work. MCU. Controller tester. Runner successfully added. Enter the name of work folder. Sure. Interestingly, it didn't actually create an underscore work folder. Maybe it's not until it runs. So then it says last step, run it. I guess I don't know if there's any output. Oh. Listening for jobs. Okay. If I refresh this page, is it? Okay, there we go. Okay. So now, let's open this repo. Let me clone this repo again. So last time I messed with this, I am ashamed to admit I accidentally deleted main in the Adafruit one and had to go back and revert it. Thank you to Carter, by the way. I owe another hug report to Carter for finding that and letting me know. Well, do we want to clone it on the Pi, or do we want to clone it? I think I want to clone it on my PC. What is it? SI 1.1. It's not really what I wanted. I don't know what's up with the git state in that one. I don't want to use it because last time I used it, I accidentally messed up the main of Adafruit. So probably I could recover, probably it's okay, but I just don't want to mess with that one anymore at all. So we're going to reclone mine. We're not even going to put the Adafruit branch for now because I don't think we need it. I find it easier to open a project that's in the same folder as the project I know I want to go to, because then when I do open, it defaults to here. And my device workspace project is in a different place. Maybe I should just move that to here, though. Runner like a cron, pretty neat. Not quite like cron. It doesn't necessarily run on a schedule. So it's not like gonna run something every hour or something like that, but runner, like, the actions can tell it to do something. So when we push to a library, it can ask that runner to do something, right? Make a build. In our case, push it to a device and test some metrics or other tests or something. I mean, I guess you could schedule it by scheduling commits to happen, right? If you, ironically enough, if you made a cron job that made a change and then made a commit to your repo, that would make your runner run on some set schedule, but it's really more of a triggered action, not necessarily as much of a time-based action. Yeah, totally. We're using, it's straight up this. In this case, we're actually directly using GitHub Actions. GitHub has a setting for making these self-hosted runners. So I'm going to make a new branch. I should have made it from this, I guess. I'm going to merge this in, because this has check sizes right here, which is the first thing I did. We might as well have that running as well. Okay, we need something to tell it to run on our self-hosted. Runs on. Why is this yellow? Oh, okay. We don't need these. I don't write YAML very much. Property runs on? Why not? Oh, does it need to be, can it not just be a task? Maybe it can't just be a task. Yeah. Okay, yeah, it's got to be this level. It's got to be a job, not a task inside of a job. Okay. Get rid of that. We just add another one? Let's start nice and easy. Find device. Find microcontroller. Uses. Okay, no, that's if we have an actions, I don't know what that's called, but we have an actions repo or whatever, which I guess we could eventually make one, but right now we don't. We're just going to be doing more like this. We're going to say run. We're not going to make build, but we're just going to go, let's just start nice and easy, disco tool. See if we can get that to run and get the output from it. And so one question maybe is, do we want to disable this one for now just to make it faster? We can iterate a little bit quicker. Does that mess up my syntax at all, though? Like, we should be all right. Okay, one thing I'm going to do, though, before I commit also is rename origin Omegai. I put YAML up there with Lua. It's a place it's a place you visit, not a place you want to live. Yeah. Yeah. I like JSON as a configuration format a little more than YAML. So one thing is, should we echo something? Maybe we should echo something just in case if it's not going to print. Am I too late now, though? All right, so I did make the commit, but I haven't pushed yet. So I guess we could go cancel, and I could say like echo running. You need quotes? Running disco tool list. On device tests. Complete. Job on device test with results completed. Success. Nice. Yeah. So one thing that is slightly challenging is that, yeah, I will agree with that. I did say earlier I like JSON as a config format, but that is definitely the one like thing I don't like about it is no comments. Definitely agreed there. So one hurdle is that right now the MPY file is not going to be on the Raspberry Pi. So inside of, well, I mean, also let's stop and also just think about what we did for a minute. That's pretty freaking sweet that we managed to add an actions task, which is connected up to a Raspberry Pi, which is able to now find a microcontroller. We haven't even done anything with the microcontroller yet, but honestly, that is like super cool. Okay, but on to the next hurdle, which is that if we re-enable all of these actions here, it's going to be building the bundles, which is the MPY files. But these are inside of this Ubuntu server. So we either need to also build the MPY files here, or we need to figure out a way to get them from this one inside this Ubuntu server to show up here inside of this Raspberry Pi. What do we think is going to be easier? Let's take a quick search on it. So these are what? These are our jobs? Yeah, from one job to another. Two main ways. It'll provide you with an action called actions cache. You can use it to upload cache, then download it. Okay. Music paused on me there. So is this key values though, or is this files? Because cache node modules, well, that's got to be files, right? Path, npm key, runner OS build, cache has files, package lock, store keys, runner OS build, cache name build. File path on the runner to cache or restore. Key to create when saving the cache, and the key to be used to search for the cache. Restore keys, an ordered list of alternative keys for finding the cache if no hit occurred with key. Cache hit. Runner OS primes. Gotta be honest, I don't think I quite agree with this. I mean, there's not a lot there, but I wouldn't call it simple because I still don't quite get. Is it a file? Like, what is it actually sharing? In this case, I guess it's a file called prime numbers. In this case, it's a folder called .npm. But it's weird too, the generate comes after the cache. Is it not caching the ones that it generates? Artifacts. So we do this with builds. Do we have anything with artifacts today? Do we add the load artifacts? Archive bundles. GitHub.workspace/bundles. Okay, so bundles will be inside of this. Bundles will get created by this command, I think. So we may be already saving it. Let's just see, let's turn all these back on and let's see if we can download our artifact from the Raspberry Pi side. Download artifact. So do we need this too, or? Part of this is my infamiliarity with using these things. I don't even know what these are called. Like, it's like a repo that is a GitHub Actions. It's like set up to be specifically used in this way. Bundles. I don't, if the name is wrong, or this has steps. Yeah, this doesn't provide names, just has uses instead of name. I guess, does it take its name from inside that repo? Okay. Okay. So one other question though is, do jobs run in sequence? because we now need this to wait for this. I don't know if it shares across jobs like this either, though. Okay, so caching actually makes more sense for what we want, but in our case, we're already using the artifact anyway, so in my mind, I think we may as well. Is there a way to tell a job not to run till another job is finished? Job sequence? Dependent jobs? So, if I understand right, what this is doing is, as the last task inside of what you want to be the first job, it's telling it to trigger the next one. So we should probably move on device into a thing called something else. And I don't know, do these just take the name that you want to use for the event type? So would we make like trigger workflow 2? .yaml? But then this would not be pull request push. This would actually be, I don't know if that's right. That doesn't seem right, does it? Oh. needs. It seems like there's too many ways to do this. The release workflow. I mean, we have a release too, but it only runs when a publish is made, which is not, that's not really what we want, right? We want to run this on whenever a commit is made, but just after the other one is finished. It's also unclear to me, does this need to be in this file, or what file should this be in? None of these like tell you what the name of their files are. Does it matter, or is it arbitrary? You just get to pick whatever name you want? Is that how this works? This will run build CI as normal on push. And this says on workflow run, workflows build CI types completed. And we probably somehow need to do successful maybe as well eventually. Some of the Stack Overflow pages we're talking about success or not. On success. But no, okay, they just named it on success, but they're using this to check if it was actually successful. Conclusion. I don't know how it would know which workflow this is targeting though, right? I guess because of the way it targets it up here? To start, yeah, let's not worry about that yet. Let's just get it to run after, and then we'll worry about success. I don't know, do they have empties at the end of these files? I don't know. Workflows or jobs? We have sequential workflows at this point. Yeah, I mean, I think it's definitely looking promising, David. Even if it is a dead end, that's no big deal, right? Sometimes things don't pan out. I appreciate the suggestion either way, because honestly, I'm thinking this is looking pretty promising, truthfully. I don't know how long you've been watching or not, David, but we did get, so I have this running on a Raspberry Pi. It found my microcontroller that's plugged into it, so like we're a bunch of the way there already as far as like the actual infrastructure to be able to communicate. Yeah, see, it doesn't have another thing listed. We only have test. I guess maybe that's because it knows it's... I mean, maybe it knows that it's sequential, though. I'm guessing I gave it the wrong name or something, and it's not actually going to run my other one. One thing we could do to speed up the iteration, maybe, is take out the pre-commit run. And also docs. Check YAML. Any licenses in the YAML files, or? Yeah, I don't think it's gonna run though. Am I allowed to, does anybody know? Anybody who has more experience with actions, does anybody know if am I allowed to just make this whatever I want, or does it need to be a specific, like there's a list of things that are valid names? Because I kind of got the sense this one wasn't even gonna run. I'll add this to it, but it's not actually gonna run, then it may not make a difference. I guess I'll just leave pre-commit. I hate to wait for it each time that we want to iterate this, but it's probably better to make it do everything. That way we don't, accidentally make it work in a situation that's not real. Fix into files. Check YAML. Valid YAML. Using Wi-Fi at the moment. Free Wi-Fi. Did not find expected hyphen, but hyphen is there. It's even on column 7 or whatever. Same thing here. I don't know. Are these different? These are different. Okay. Yeah, see this one, right before the hyphen there is index 7. Right before the hyphen there is index 8. Hmm. Same problem. Yeah, it does not help that I don't know the YAML syntax at all. I don't know what's valid, what's not. I don't know what the hyphen means. I don't know what any of this stuff is. Boy, the PyCharm is not very good about the syntax for YAML, I guess. It's, you know, like if I had invalid JSON or whatever, it'd highlight it for me, and I guess it does highlight. Like when I messed this up or whatever, it gives me a big yellow, but it did not understand that that was broken. Oh, what? What is this? I forgot. There's a fix. This is because I pressed Control S. Is it Control Q? Whoa. Made it run the thing. That's weird. Okay. That's passing. I still don't know if it's going to run. Howdy, everybody. YAML. How's it going, Dexter? Thanks for the link. I can try that. Is it? Well, let me try running this one how it is now, because I think I did get it there finally. Is it? Does that thing highlight your errors, though? That's the main thing I need, is like to find spaces that are wrong. Yeah, we'll try pushing this. I'm not sure it's gonna run. I feel like we need a different name for this, or I don't know if it's supposed to be inside a build as... Well, no, it needs to be its own thing, because we need this bit. Yeah, I don't know if this is... Well, okay, first of all, I guess, though, we shouldn't call it this, because that's what we already have. Yeah, that's no good. This should be... maybe this. Yeah, see, the way it only has tests listed here... makes me think it's not going to run. And I guess the way it has build YAML here, but no trigger workflow to YAML. But maybe it knows. Maybe it knows it's sequential. Maybe it'll spawn that one after this completes. I mean, it does... I guess that would make sense, right? Because we did tell this, like, run when this one is completed. So I had something like, oh wow, this changed it. This moved these onto their own lines. I had something kind of like this, where this was off by one space. Yeah, that's pretty much the same error I got, but I didn't understand it enough. I guess though the key is just look around the line and make sure things line up. Okay, this completed. No. We did get artifact bundles, but it didn't run the other action, the other workflow. Workflow? The workflow. Oh, hey, there's this though. This is from 11 minutes ago. Why is it? Oh, well, it would be 11. I see. I see. Well, that's weird. So it did run last time, but not. But I guess that's probably because I had it at the end of the one to say, like, start running the other one. But I changed the way I was doing it. Did I ever push like that, though? I don't know if I ever did push. I had that step at the bottom of this one that was like, start the other one, which that seems to have actually made it start. And it just had an invalid workflow file. So maybe we should go back to that. Maybe we should put that thing that launched it. It says valid. Property on is not allowed. Hmm. Alright, let's go way back here. Let's take several steps back. What is like the basics of actions? How do we tell it what files are going to run? No, I don't care about this. How do I tell it which files are going to run? Basic stuff here. First interaction. Action.yaml. Oh, this is like user's first interaction. How do we choose the name for the file, though? Like, why is one build and one release? Are those arbitrary choices? That looks pretty arbitrary. So I don't get then why this one didn't run. I guess this didn't trip. This didn't get triggered for some reason. Hmm. Doing a second job inside the same workflow YAML together with the needs workflow. Create a separate notify.laml workflow. Use the workflow run event as a trigger. There is, okay, we could do this. Needs. This is what we're currently trying to do now. It's not actually working. I don't quite get why it's not working though. It seems like we're set up pretty much the same way. But why didn't it run this time? Hmm. Okay, this is main. I don't know. Okay. Let's comment all that. In workflow, separate job. Go back like that. Oh, but now we can't do that. We can't do that because... Okay, no, yeah, we can. This is gonna be all sorts of wrecked. Did auto format and it changed a lot of stuff. Oops. Okay. And then needs. Needs. Test. Nope. Oh, end of file? Why do I get 2 lines? Oh, come on. Really, that unchecked? That means we're going to get 2 separate runs as well. Okay, that's what we're looking for. This one has to complete before we can do this one. Assume that's what that little line means. Didn't somebody make a CircuitPython PyTest or something? Hmm. I want to say maybe there was another effort for this as well. This one shows archived. Oh, okay. Check bundle. No such file or directory. Hmm. Okay. So that bit worked. The download artifact appears to have worked. But I don't know where. I don't know where we're at in this context in here. I guess I assumed we'd be in the directory wherever this downloaded the thing called bundles, but it looks like this is saying here. Okay. They didn't come through as bundles. We actually also, we have the zips as well, so we're gonna have to unzip them. We gotta find them first. So maybe instead of ls bundles, let's just run ls and maybe pwd. Try to get a look at where we're actually at here. We're getting close. We got our bundle onto the device. At this point, we just need to unzip it, push it to the microcontroller, and then run our test on it. And I think in order to do that, what I'll do is I need to push this memory measurement. I'm actually gonna move this out to here. Because eventually our action is going to clone this repo to be able to use this Python code inside of it. After we push the MPY file to the microcontroller. Running job. Okay, we're already in the directory with it. Okay. So we need to unzip it. Why are there two? Is that published version and then commit version? I don't. None of those are the current commit. There's one. Okay. What is C7DE? What is this one? Previous commit. Hmm. can we get the hash inside the action so that we make sure to get the right file? I don't know if that's the right way to do a shell variable. Yeah. I'm actually curious too, though. I don't know. Let's look at this one also while we're. All right. And we wait again. I will say this is the one downside of iterating through this process is like this takes what, a minute and a half or 2 minutes or something to run this each time. It is weird that it has the previous one. I would think it would make sense to be the published one, so that way if you wanted to compare with. But I guess, will that always be the case? No, because you could just have 2 commits in the same PR, and then you would just get current one and previous one instead of published and current. Oh, I didn't run pre-commit this time. Play it passes. Nope. Yeah. So I should probably just install pre-commit. Build YAML. End of line. Why do we get 2 lines? We didn't have an end of line. I made 1 new line and then we got 2. Whoa. Why is this like draggable? When do we need to drag and drop the results of our GitHub actions? What does this even do? This didn't even do anything. What do you do? What is your purpose? Octitian screen full? Octitian screen full. I mean, it doesn't get any bigger. I don't know. That's weird. All right, while that's running, I'm gonna go into the restroom. Actually, I'll be right back. All right, we are back in time even. Look at that. We do still have this output running as well. You know what would be cool is on your Raspberry Pi, it can also run Blinka stuff, right? So we could hook up a NeoPixel strand to turn like yellow when a job is running and turn green if it was successful or red if it failed, and then you could also see not a Git repository. Not a Git repository. So this didn't work. Oh, Git. I see. Yeah, that's not working. Maybe we just do this. Fortunately, that means we get to wait for another run. Yeah, status lights would be super cool. I know Cadney worked on status lights for actual actions workflows that run in the GitHub cloud. But this would be cool because like the Pi is the thing actually running it. That'd be neat. So that be nice feedback, like for people who do set up the Pis to help us run these things, to have an at-a-glance way to know, like, is it currently working right now or not? Oh, is this running every time? Oh, cute. Now we're running this file. This file is actually running now. But it's empty, and therefore it's being weird. Why didn't it run the time that I tried it that way? I guess we'll delete it. We went back to the separate job in the same file. I don't know if that will end up making sense, though. It might make sense to actually have it in a different file, because I could also see, like, it might not be the case that we want it to cause the actions to fail. Like, especially right now, my intention is just to print more information out, not necessarily, like, automatically prevent merging. in any given scenario, just like print some quantified information so that the reviewer can take it into consideration when deciding whether or not they want to approve and or merge. So it might make sense to put it in its own one that has a less strict like failure mode, especially because you have to consider like we could have hardware issues as well. Like maybe actions communicate successfully with the Raspberry Pi, but maybe for whatever reason the Raspberry Pi is unable to successfully communicate with the microcontroller. You know, in that case, do we want the actions to just fail and you're not allowed to merge, or do we want it to just like print the warning like, hey, we tried to run but the microcontroller was gone or something went wrong so we couldn't do it right now? It's food for thought for sure. I don't know which way we would want to go on it. This completes like a second or two before the output is here. Oh. Oh. It's not this one and last one. It's every one we've done. Doesn't clean up after itself. Ah, I see. Okay. Okay. I think in that case we want to clear them out. Because I was going down the road of like, look at the hash and then use the hash to figure out which file is the current one. But if we just delete them before, if we delete all the old ones before we download the new one, then we'll only have one. Well, we'll have like one set, you know, one Pi file, one examples file, one JSON file, one 8.x, one 7.x. We'll have one set of those. We won't need to know about the hash and try to compare. Just clean up bundles, maybe? Clean up bundles. Why does this default to this? It's like, maybe this is part of why I find YAML difficult, is my editor doesn't seem to write it correctly. See, yeah, I got this dash again. I don't know why I keep getting these. So we got to be careful with this. We want to go like rm dot slash. I'm just going to stay maybe like star.zip. So delete all the old zips, and then also rm dot slash star.json. Basically, we delete all the old zips, all the old JSONs. So we probably won't really need this. I don't know if that's how you comment it out. Let's run another one that says ls star 8.x star.zip. Yeah, let's see if that correctly targets the 8.x MPY. We want the MPY one though. 8.x-MPY actually. Let's do that. Okay. So if this outputs correctly, then the next step here will be like unzip it, copy it to the device, run the memory check thing on it. There we are. Simple, see? Very simple. Not quite that simple, but hopefully we're gonna make it simple. I'm getting better and better feelings about it as we go on here. Like, I will say I'm maybe not, like, I don't have a lot of pre-existing actions knowledge, so I'm not the best at troubleshooting some of this, or YAML either, which I think is also probably helping make it more difficult. But I mean, if I can poke my way through it without any experience with either of those things, really, then I feel like that's a pretty good sign. Why don't we clean up some tabs here? This one was about cache. I think we're good with artifacts, though, honestly. Like, if we hadn't already been uploading the artifacts, and if it was up to me to right now figure out how to do it, it seems like cache would be the proper way. But since we already have the artifact, and I assume we're already probably using that for other purposes, very least of which being like you could send somebody a link to download it and ask them to test if it fixes their problem or whatever, right? Same way we do artifacts in the core. Since we already have it there, I think just downloading it from there makes a lot more sense than also doing the cache. I'm good with that. One thing we should test is what happens to this if the pi is gone. We got our cleanup here. Got our download. There's our LS, which has way less stuff in it this time because we deleted the old stuff first. Not quite sure what this is about. And we just have another file here, and another file here, another file here. Huh. Unexpected EOF while looking for matching. Quote. Did we misquote it? I see. I see. Well, that's a bummer. Now we wait again. think what we'll do is maybe end up modifying this to actually take the module name and the MPY file. And I think we'll add some bits to this that allow it to push the MPY file to the device. I guess, though, we will need the file path as well. This is actually the serial path, like /dev ttyacm0. We'll need the file path as well, I think. Disco tool will help us with that, though. So there's disco tool REPL. That'll let us get to the REPL without caring about the path. Although I'm less sure, how do I use this from inside of another script? Because disco tool REPL... Like, can I do a one-liner that opens the REPL and executes a thing, or... I'll have to figure out how to get into the REPL and write my stuff to it. Or I guess the other thing is, though, I could also just use disco tool to find the device. And then once I have found it with that, it contains the path as well as the file path. And once we have those two things, we could actually just be doing the same thing that this script is today, which is connecting using, I think, PySerial. Or, yeah, serial. Maybe we'll plan on that. We'll use disco tool to find the device. I would write a Python script using PySerial to inject stuff. I will mention too, David had another decent idea in those notes back at the very beginning of the chat when we started. Another thing David mentioned was, instead of using REPL, we could actually be like writing CodePy and then waiting for it to output its results somewhere and then reading them from there. I do think that's an interesting way to go about it, but I lean towards REPL because with REPL we don't have to make it writable, the drive. So like if we did CodePy, we could have CodePy run and CodePy could output a text file or JSON file. And we could read that, but it would need it would need to be able to write to itself, which then also complicates our ability to push library files to it. But if we go REPL, then we don't really have that issue. We never need to have writable on or whatever, so we can just push files to it, read the output out of the serial anyway. We're already there, so we might as well just be using REPL also, I think. Here we go. So there's our ls. Nice. There's our file. Okay. So now let's work on making this work with a zip. Let's say this is also going to take zip file, module name. I'll keep device path for now. Whoops. We need to unzip it. Okay, let's cut out a few of the middlemen. Let's just make sure this actually works on the Pi. Lister. Okay, now we have a folder. Inside of there, it has lib. Inside of lib, it has the MPY file. Eventually, we're also going to need to work this out for modules or packages or whichever one is multiple files. Right now, this pretty much is hard-coded to work with only a single MPY file. On Unix bash, this would work, I think. REPLs, disco tool get REPL, for REPL in REPLs, do echo some commands. REPL. Interesting. Disco tool get REPL. I may try that. I'm gonna, if I can, stick to Python scripts because I find Python easier to write and understand than Shell personally. So let's make another one of these def unzip file. We saw that this worked. We'd go for a Python script. Path to file. So this is where we will this will be zip file. Directory to extract to, this will just be /. Push file to device. Device file path. Serial path. File. Device libs. West.system. CP file device file path /lib/ So then we're gonna try unzip file, push file to device, file. So it's gonna be zip file. Let's actually do this. MPY file equals zip file dot replace dot zip with nothing. That gets us to the folder. Gets us to the folder, so then we go /lib / module name .mpy. And again, we'll have to figure this out for folders still, but I think this was just the zip without the zip, so we went inside there, inside that's lib, and inside that is our MPY file, which has the name of our module name.mpy for right now. So unzip it, and then might as well, I don't think it matters because this is just a string with the path, but we might as well unzip it and then create this variable, I think. I don't know why I did this leading like this either. So we're not going to be doing name main. We're going to import it and run this function. I'm gonna again skip the actions and just run this local on the Pi, and let's get it to the point where we actually think it's gonna work, and then we'll go back and add it to the actions. That way we don't have to wait as long between iterations here. So I'm gonna clone this. I guess I want to copy the thing out of it, I think. CP, copy that up to here. And now we're going to go Python from on IPython? From on... No? Oh, did get it. Okay, I just took a minute. Well, we're on the Pi, I forget. Yeah, it's not as fast as mine. So from this, import... What did I call that? We probably need to change the name of it now. Get RAM size. And now we need to basically fill in all these things. Nope. So these are going to be what we fill in. Here. Need to stop using tab complete. I rely on tab complete so much, but it's actually slower than typing on the Pi. Okay, so zip file is first, which is going to be this. lib si 1145.mpy. Module name Adafruit si1145. Device serial path. Device file path. File is not a zip file. Did I get this bit wrong? Do I need a dot slash also? File is not a zip file. Well, we already unzipped it though. Already unzipped it. Oh, I'm putting the MPY file, but it needs to be the zip file. Shoot. Yeah, duh. That's it. So I think the unzipped worked that time, although it's tough because we actually already had one, so we wouldn't really be able to tell. We could go rm-r, delete that, and then rerun it again. See if the unzip worked. Does seem like it worked. The other thing we could check is, did it actually push to our device? We do have this here, but I don't know, it may have been there before, so let's go rm mediapy circuitpy lib Adafruit. Rm this. Then let's run this one more time. I know it's still going to fail the same way here, but that's fine. We're just going to check if this got unzipped and moved to our device, and it looks like it did, so we're actually pretty close. What is our next problem here? Module name. A bytes-like object is required, not a string. Do we just need module name to be a bytes like this? Probably we could convert it with like encode or something. For now though, I'm gonna actually just go here like that. Cannot stat. No such file. Cannot stat? I don't know what that's from. It doesn't have like a traceback. We got a RAM size though. CP. It's from our CP command. But it did copy it. That's odd. Have size? Yeah. That's a size. Cannot stat. No such file or directory. Oh, Adafruit. We need to convert this back to a string. Regular string. Decode. Okay. On device RAM check. Do that to here. Python-m import from on device RAM check import get RAM size. Print get RAM size. I think for now I'm going to go ahead and hard code these. We'll have to like use the output from this to get the first value here ultimately. But for now I'm actually just going to hard code it because if I just want to see if I can get it to work. I'm probably going to wrap up pretty soon here. But it would be awesome if we could get it to go one full cycle from an entire all the way through an actions push to getting the stuff from the device. Oh, although it's going to be hard because this won't be the same. How do we want to do it? I really want to get it to run all the way through without solving the rest of the problems, like how to find the right file. Let's get rid of this. So now this will be able, it's not going to delete the old ones, so they'll still be there. Okay. This line is going to get ultra long. This one was bytes. I'm going to hard code these also. Okay, so we'll run it against the old commit, which is all right for now. We just want to make sure that it's actually going to unzip it, copy it, and do all the right stuff. So what I'm going to do is, before I even run this, we're going to go back here. We're going to delete that so it's not on our device anymore. We're going to also delete it, the unzipped one. We're back to just this. We're going to make our new commit. It's going to end up getting a second copy of all of these things. We're going to unzip the copy we have now and test that one. Eventually we'll figure out, though, how to find the right one for this. I think all of this stuff should work. Okay, I deleted the library from the device. I deleted the unzipped folder. Is there anything else we want to clean up before we let it run? We took out the cleanup section, so it's not going to delete the old ones anymore. I guess I don't know if this is valid. Okay, we did pass that. I think we're ready. Can't think of anything else. Oops. All right, fingers crossed. Now we wait. I do think I'm probably heading out pretty soon here. I'm hoping that I will get a success on this, so I might try another couple times if we don't get a success, because I would love to see it work all the way. But I'll probably head out after that, and if I don't get it after a couple more tries, then I'll probably still head out. But I'm thinking we're good here. I got some confidence in this one. I feel like we worked through all of the issues. I pushed this, right? Memory, this is pushed. Yeah, so we have the latest version there. You know, one thing that's weird is did I ever pull again after I pushed this? I don't know that I did. But we got it working. Maybe I did. Maybe my clone was after that. I don't know. I don't know the timeline anymore. Whoop. Okay. Uh, deleted that, I guess. Okay. And this, actually. Actually, we could just rerun it, right? We could just rerun it. Could we? Like here, rerun jobs? Rerun all jobs? Rerun all failed jobs. That'd be nice. We don't have to wait for the first half. We didn't actually change anything in the workflow file. Just deleted it in the actual environment it's running in. Nope. Import by file name. I have a .py somewhere it shouldn't be. Import by file name is not supported. I feel like we're so close. This has got to be here. Does it... Hmm. Import by file name. So it does cloning. I assume the clone worked, and I assume the copy worked. So we didn't get any errors outputting for those. And our error came from Python. Whoa, I think we need Python 3. Let's try running this also. Module not found. Does this not work how I thought? Isn't -m how you... Can you not execute? This is not executing it as Python code? How do you do that? What does -m do? Is that not? I thought that was how that works. No module named print. And I guess I could write it to a file and then execute it. I could have swore there was a way to do this. I'm not finding the... I'm not searching right. I think there probably is a way to do this, but my search is... I don't want to execute a script. Code. Just code only, no script. Skip. Yep. Yep. No, this is running .py file. It's not what we want. Can you not just execute a Python just code from the command line with the CLI? I swear that's a thing you can do. Am I crazy? I mean, I guess there's some way I could rewrite this to where it would work with -m, but I also don't know what -m is and am failing to find documentation for it currently. Run library module as a script. -c. C. Command. Program based in as a string. Yes. Thank you. -c. There we go. Thank you, Dexter. -m pip. Yeah, I've seen that one before. For some reason, I was thinking -m. The other one I remember using -m for is http.server. But I guess those, it's like importing it for you, not executing it. But now we got this. I think we should be good. And that even ran successfully. We're going to do this. We made a real change, so we don't need that comment change. Looks like I got rid of it anyway. Okay, so this will rerun everything again. It'll be interesting to see the relation between MPY file size and RAM allocation. I don't know if that's like going to be 1-to-1 or if it's even going to be a consistent ratio, or if it'll just be all over the place based on the library and stuff that's over my head, basically. Good way to make sure you launch the pip version that matches your Python version. I gotcha. I have circumvented that problem by only having Python 3 and then just updating it. So like if I want Python 3.8, I updated to it and got rid of 3.7. And I don't even have Python 2, although I guess maybe the Raspberry Pi probably does have Python 2, which is ultimately where this is running, so. Oh, I didn't delete the stuff. Oh no, oh no. Ah, why? Think we made it? I think we made it. I think we didn't get rid of the pre-commit, huh? One 1572 bytes, 858 strings, 54%. I will say this runner thing is pretty cool. This thing has managed to just run and do its thing. We haven't had any issues with that portion of it. So that does, I mean, I am liking the infrastructure here. Because this is especially nice to not have to need an actual central server that does this stuff. Being able to have the clients connect directly to GitHub and just become actions runners. Oh, I think I saw it. Boom. It's not very pretty. It doesn't output any labels. We're looking at several commits back, although we haven't changed the library code anyway, so those commits, the actual library is the same, but we got the printout. And it is much larger, actually, so under here, the MPY file size was 1572, and the actual space in RAM is 4112, so it's like over double the amount of space, which is pretty crazy. Interesting. But we got it. We made it. We've done it. Not really. We've done the beginning. We've done the proof of concept, which is a big step. Much more to go, but I'm pretty happy with this. So to recap, we have a Raspberry Pi running as a self-hosted runner for GitHub Actions. We added an action to one of the CircuitPython libraries that will use the self-hosted runner and have it import the build of the MPY file that came from the other action, the existing action. It will copy it to the device, it will import it, it will get the size in RAM and print that out inside of our secondary action here. And we could also build all kinds of logic that says, like, if it's over a certain amount, then it turns red or it turns yellow or something. If we wanted to, we could have these like fail or something. Right now I'm just having them print out, but we could actually build logic that says, you know, how big is too big, and like we fail once it goes over a certain amount or something. This is so cool. Yeah, thank you. I definitely agree. Okay, I am gonna head out for now. Thank you everybody for watching. Thank you Dexter for the -C tip. Thank you NearDoc for Disco Tool and all of the help and everything you do, honestly, in the Discord and everywhere. Let's see, who else joined us? We had a couple other folks. Thank you David G again for the idea. Johnny, DJ Devin, thanks for hanging out. Paul Cutler, thank you as well. NearDoc, I think we got everybody there. Yeah, so thanks everyone. Hope everybody has a good weekend. I will catch you next time. I don't know. Let's see, I'll be streaming probably on... well, let's see. It's CircuitPython Day on Friday, so I definitely have a stream Friday evening. And I'll be on the panel also, so yeah, heads up for folks, CircuitPython Day panel. Thank you to Paul for all the work you've done to organize that. That panel, I don't know the exact time of it off the top of my head in the correct time zone, but that's on the 19th, so tune into that. And yeah, thanks again, everybody. I'm super excited about this. If anybody has insight or interest or wants to help tinker away at this, my code is pushed under that memory tools repo. This one, CircuitPython memory tools. So this is my code that does the actual checking, and then my branch of this SI 1145, this self-hosted runner fun. This branch is the one that's got that stuff on it. So if anybody's interested, you can clone that and check it out. If you have a Raspberry Pi, you could try running it on your side as well. And yeah, I'm out for now. Thanks, everybody. I'll catch you next time.